Okay, so from the previous example, example 2, we learned that not all x values are appropriate for our sum. So if you have, for instance, a sum that says 2 over x equals, say, y, we need to know that x cannot be equal to 0. Okay, because if we ever find that x is equal to 0, then our equation becomes undefined. And so now that brings in a word called restrictions, right? We want to find the x value that works, but there are certain restrictions, certain rules that we cannot break, because we cannot end up with an equation that is undefined. Okay, and so when we look at example 3, the first thing we need to do is figure out what x should not be. Should we ever come to that answer, we know that that answer is not applicable because it will make our equation undefined. So let's have a look here. When will this be equal to 0? Take a second to think. Yes, when x is 1. So when our x value cannot be equal to 1, because when it is equal to 1, then our equation becomes undefined. Okay, so now we have a little restriction over there. X cannot be 1. Now that we have our restriction and our rules in place, we can try and solve this equation. So the first thing I would like to do is get all of these guys to look like fractions. So we go x over 1, and we make this 2 over 1, right? At this point, I'm hoping it's clear that the LCD is going to be x minus 1. Okay, so now we found our LCD. Now we go ahead and multiply each term by said LCD. Alright, so now that we multiplied each term by the LCD, we go ahead and see what we can do. Alright, this will cancel nicely. Okay, at this point I'm okay because these denominators is just going to be 1. So now we go and focus on the numerator. We get x squared minus x is equal to 2 plus 2x minus 2. Okay, so there we have this equation, and now we solve this as far as we possibly can. So we get x squared minus x, we bring that over, minus 2x is equal to 1. Okay, sorry, is equal to 2. This here should be negative 2, so this is going to be equal to 0. Now we're left with x squared minus 3x equal to 0. Now to solve this quadratic, we need to go ahead and factorize. So we go x and x minus 3 equal to 0, and that leads us to two solutions, one where x is equal to 0 or one where x is equal to 3. Alright, at this point we take a moment and we check if any of our answers defies our restriction, and in our case our solutions are not giving us 1, and so therefore both of these solutions are suitable for our equation. Okay, I said to you, you can always check if your answer is right. So let's just go ahead and try it out with the 3. Let's make x 3. So we say that 3 is equal to 2 over 3 minus 1 plus 2. Okay, that is what we are substituting into this equation. So we say 3, is that actually equal to 2 over 2 plus 2? Well, yes it is. 3 is in fact equal to 3. So my left hand side and my right hand side are equal. So that means my solution is correct. My solution is making this equation true. When x is 3, this blue value is equal to this orange value plus that blue value. And so I only tested the 1, but my solution for this equation is correct. Before you watch example 4, I would like you to try the following question, and I want you to please type your answer in the comments. If your answer is correct, I will like your comment, and that's how you will know that you gave me the correct answer. Thank you for watching.